Marine engineering literature often fails to distinguish between kinematic models, or some might call mathematical models, and digital models. So there's a significant, there's a significant confusion between kinematic and digital models. A kinematic model in the context of shift maneuvering computationally describes the vessel's motions in the time domain. These kinematic models form the core engine of digital simulation platform. A digital simulation platform, on the other hand, or we might also call this a digital model, represents the ship's time-dependent response, which incorporates the actuators and their interactions with the surrounding environments. Ship digital model is the entry level in digital twin development. So digital twin is actually the final goal. Digital model is the entry level. It is a purely synthetic model. This synthetic model is constructed based on ship motion equations. However, it lacks any interaction with the real world data. So it's only inside our computers and doesn't have any connectivity. The system is manually controlled by a human operator or an input script, and its purpose is to provide a simulation-based test bed for early-stage design and analysis. The digital model operates without physical sensors, relying entirely on direct input from the operator. So Mansim, which was our previously published code, this is a freely distributed software. It is actually a digital model. Let me show the screen, share the screen and show it to you. Okay, so this software is actually a digital model. For instance, you could select the different math models here. Let me just quickly select. I don't want it to take that long. For instance, here I will select a ship. I couldn't do it. So this is actually the digital model. You can import all the details of the ship here. The left-hand side has all the hydrodynamic and geometric properties of the ship. The right-hand side is dealt with the dynamics of the ship hull, propeller parameters, rudder parameters. So every parameter that you enter here, when you click run, it predicts the ship's response according to it. So this is actually a digital model, but it has, as I said, no connectivity with the real physical world. Back to the presentation. Okay. We divide the ship digital model into two progressive levels. So the ship digital model is shortly abbreviated by SDM. SDM level 1 is manual control. SDM level 2 brings the controller prototyping. That means the first level, in the first level, human operator directly inputs actuator commands. So looking at the left-hand side, there's a human user. It gives commands to the model, the mathematical or the kinematic model, and the response is visualized in the computer here at the left-hand side. At the right-hand side, which is level 2, human user gives the desired states. This ST is the desired states. The controller generates the actuator inputs. It gives those inputs kappa to the kinematic model, and kinematic model gives the response of the ship to visualize in the computer screen. So this is the two different levels of ship digital model.